Welcome to another of my videos where I work through and explain A-level physics multi-choice questions. If you want to try this question yourself, pause the video now. If you got the answer C, give yourself a pat on the back. If you'd like to see my explanation of how I found the answer, please continue watching. So, a diffraction grating is illuminated normally. The second order maximum for the light of wavelength 650 nanometers occurs at the same angle as the third order maximum for light of wavelength lambda. What is lambda? So what we've got here, we've got a grating through which we're passing light, and that's being projected onto a screen. And we'll get a maximum in the middle, and then we'll get maximum from the diffraction pattern spreading out. That middle one, the one that's straight through, is called the nth order. Then we have the first orders, second orders, etc. If I draw a normal line to that zero order, then we can see that these different orders will make a different angle theta. And that's given by the equation d sine theta equals n lambda. D is this distance between the slits. Theta is this angle here that we discussed. N is the nth order of the maximum, and lambda is the wavelength of the light. So it's saying that there's a second order maximum for light with a length of 650 nanometers, and it occurs at the same angle as the third order maxima. So if the angle is the same, then sine theta is the same. We're not changing the slit, so we can say that for both these cases, sine theta is going to be directly proportional to n lambda. And in case 1, n lambda is going to give a certain value, and that value is going to be the same when we change the wavelength of light to theta. So in the first case, n it's a second order maxima, so I can say n is 2, and that's multiplied by a wavelength of 650 nanometers. And that product, that value there, must be the same when we look at when we change the wavelength of light, because it gives the same angle. Therefore, sine theta must be the same. So that 2 times 650 nanometers must be equal to the third order multiplied by this unknown as yet value lambda. So therefore my new value of the wavelength is 2 over 3 multiplied by 650. Put that into my calculator, and lambda comes out to be 433 nanometers. Answer C. I hope you found this useful. If you did, please leave a like and a comment below, and I hope you'll watch more in the series.